Okay, let's start with a quadratic function. Let's say we've got a quadratic function, ax squared plus bx plus c. Let's say this quadratic have two roots. Root is also called the zeros, i.e. the x-intercepts. Okay, x-intercepts are also called the roots. That means let's pretend it's got two roots, alpha and beta. Whatever they are, they're just two roots along here. That means because they're x-intercept, I can say that ax squared plus bx plus c is equals to 0. If I solve that, I should be able to find what alpha and beta are. Now, because this entire equation is equals to 0, I can divide everything by a to give him a squared plus b on a x plus c on a equals to 0 on a, which is 0. Okay, so I can rewrite that like that, and that means the roots are still alpha and beta. Now, based on this thing, because it is, if we have roots alpha and beta, I can also say that ax squared plus b on ax plus c on a is completely factorizable to x minus alpha times by x minus beta, which is the standard factorized way to, if you know the two roots. Okay, so that means this is equals to, I'm going to expand the right hand side, x squared minus alpha x minus beta, alpha x, okay, minus beta x plus alpha beta. This means I've got x squared minus, let's say, alpha plus beta x plus alpha beta. All right, so that means I've got the original quadratic, okay, is equals to the factorized form in terms of alpha beta if alpha and beta are the roots of this quadratic formula. Right? That means if I equate the coefficients, that means b on a is equals to negative alpha plus beta, and that also means that c on a is beta alpha times by beta. In other words, for quadratic equation, okay, alpha plus beta, well, negative alpha plus beta equals to b on a, which means that alpha plus beta is equals to negative b on a. That is called the sum of roots. And I can also say that alpha beta, whoops, let me just rewrite that. Okay, alpha beta is equals to c on a by equating the constants, and we've got the product of roots. Okay, so that is a general rule for quadratic formula for sum and product of roots. This is the sum, this is the product.